Hello everyone, now I want to continue the conversation of relationship between mole and mass. Previous podcast we discussed the relationship between the 1 mole of any given element is equal to the molar mass of in grams of that particular element. And actuality, in general, the definition of that is 1 mole of any substance is equivalent equals to molar mass in grams of that substance. And in this here we're going to want to extend that concept out a bit. So as I stated before, in the previous podcast, it is clear the molar mass of elements equals the atomic mass of corresponding elements. So if you want to know 1 mole of any given element, how many grams is equivalent to that, and you can actually check on the periodic table, get the atomic mass. The average atomic mass will be the molar mass of that particular element. For instance, let's take a look at some examples. We say 1 mole of hydrogen is equivalent to 1 gram of hydrogen, because 1 is the atomic mass for the hydrogen atom. Let's take a look at 1 mole of oxygen atom will be equivalent to 16 grams of oxygen atom. And the list can be going on and on. 1 mole of carbon will be counted as 12 grams of carbon. And 1 mole of nitrogen will be equivalent to 14 grams of nitrogen. And those relationships in the previous podcast are used to calculate between the mole of the element and the number of atoms of that element. Then how about the molar mass of compounds? And for instance, how about the molar mass of the water, H2O? And how do you go about it? Actually, I want you to pause here for 5 minutes and get a piece of paper, start to derive the molar mass of the compounds. Okay? So now time is up, and let's take a look at it. And one thing we know for sure, for the water molecules, it's being represented, it's a pure substance, it's being represented by this formula H2O, and it's a compound. Later on we're going to learn laws of definite proportion, laws of multiple proportion. It will clearly lay out, you will just say like 1 water molecule will have 2 hydrogen atoms and 1 oxygen atom. Okay, so you can use this extrapolation. You can really say 1 mole of H2O will be equivalent to 2 mole of H, and will be equivalent for 1 mole of oxygen. And now you start to see, oh, actually the molar mass of H2O is probably with the molar mass of each element that is composed of that makes up the compound H2O. Okay, so the Molar mass of that will be the summary of all the molar mass of each element. And in this case, if you have 1 mole of water, you have 2 moles of hydrogen, and you can actually convert this 2 moles of hydrogen into grams of hydrogen. And it turns out you can actually use the monkey bar. You can actually use the monkey bar to do that. That would be mole of H grams of H. Will be 1 mole of H equals 1 mole of equals 1 grams of that. So for the H will be 2 grams of H per in 1 mole of the water molecule. Same token for the O, you quickly figure it out, it will be 16 grams of O. And you add those two together, you have 18 grams of H2O. And that will be the molar mass of the water molecule, because you started with 1 mole of the water molecule. And alternatively, I actually came up with a system that is going to help you master this and actually keep a much better shape in bookkeeping. So let's demonstrate you to that. I like to change the color of the pen, and in this case I want to actually go blue. Essentially, you're looking at the formula of the compound. You learn that in elementary school and middle school. So for the formula of water, that would be H2O. So in this H2O, you'll have how many hydrogens you have? We're going to have 2. How many oxygens we're going to have? We're going to have we're just going to erase and cross it out. We're just going to have 1. So this is the number of the atoms. Or sometimes you can understand it actually. If you have 1 mole of water, you have 2 moles of hydrogen, 1 mole of oxygen. And here comes the atomic mass for each element. And for hydrogen will be 1 grams. 1 grams of hydrogen will give you 1 mole of hydrogen molecules. Oxygen will be 16, and you actually start to multiply these two, and you can get 2 and 16. Add them together, you'll have 18. So you have 18 grams of H2O. So it gives you the same answer, but the approach is slightly different. Okay, and it's literally just a format issue. And as a kind of reiterate, there was the concept of molar mass is 1 mole of any substance, and you can add up the masses for each individual elements, then add it together. So the molar mass of a compound is the sum of atomic masses of all the atoms that are part of the compound. As soon as you can generate that, and you can actually start having you can have the conversion factors like mole over mass, mass over mole. So you can help you in the subsequent calculations. Okay, in the subsequent calculations. Let me pause here. So now let's take a look at some examples. We just did the water. Let's take a look at carbon dioxide. Carbon dioxide has a formula of 1 carbon, 2 oxygens. So now you can write the entity of those elements here. They will have to be carbon. How many do you have in 1 molecule? It will be 1. How many of the oxygen you have? It will be 2. And then you're looking at what is actually a molar mass of carbon, you can actually go to the periodic table. It's approximately 12 grams per mole. What would be the oxygen? It would be 16 grams per mole. And then you start multiply this, and 1 times 12 is 12, 2 times 16 is 32. So add all of those together, you have 44. Okay, you have 44 grams of CO2. What it merely means is 1 mole of CO2 is equivalent, it's the same as 44 grams of CO2. Okay, so then that's one example. Let's take a look at another example called aluminum carbonate. Later on, you're going to be kind of required to know how to put it together and actually to memorize the structure of the carbonate polyatomic ion. It turns out, and the formula unit for aluminum carbonate has to be represented by this, as represented by this. So then let's pull them apart. So this one you have aluminum, you have carbon, and you have oxygen. So how many aluminum you have? 2. Just take a look at the subscript. How many carbon you have? Now it says you have 3, because that subscript means anything within the parentheses will be repeated. The total times in there will be 3. So you need to distribute the 3 inside the parentheses. So then oxygen you have, it will be 9. And molar mass for each compound, and aluminum will be 27. And carbon, obviously, we should be familiar with, is 12, and oxygen is 16. So now you start multiply those 2 columns, generate the third one with the cross multiplication. It's 54, 36, and 144. Add all this together will give you 234 grams per mole. Okay, so it's 234 grams per mole. That's the molar mass for the aluminum carbonate compound. So now we are putting the molar mass, the concept, into solving practical problems. As shown here, you see the question is how many grams of silicon dioxide are there in 3.6 moles of silicon dioxide. So one thing you're looking at it's silicon dioxide. You will have this, and you have silicon 1, oxygen 2. Silicon will be half. The molar mass about 28. Oxygen will be 16. So the multiply the columns, so it's 28 still here, and 32 is showing up. So add all those together, you can get 60 grams of SiO2 will be equivalent to will be equivalent to 1 mole of the silicon dioxide. So now you have 3.86 mole of silicon dioxide. What you want to have at the target, you want to have grams of silicon dioxide. And here comes the powerful monkey bar approach, factor labeling method. And essentially you can just say mole, I have to put the mole underneath, okay? And now you start having to say, oh, I know how to do it, because you simply fill in the blank. 1 mole of silicon dioxide will be equal to 60 grams of silicon dioxide. Mole cancelled, you got the right unit, and simply carry out the mathematical operations. In this case, it will give you 231.6 grams of SiO2. And in this case, the sig fix has to be considered. So this one is 2.32 silicon dioxide. Okay, so this is problem number 1. So let's take a look at problem number 2. How many moles of iron 3 oxide? And the formula is right there in 8.34 times 10 to the negative 2 grams iron 3 oxide. So iron 3 oxide. And what you have here now is you need to know immediately and realize you need to know the molar mass of iron 3 oxide. Iron 2 oxide 3, and iron is 55.85, and that will be grams per mole, and oxygen will be 16. And then you start multiplying those, and this will give you 111.7 grams. This will give you a 48. Add all of them together, 159.7. That would be the grams. That would be the grams per mole of Fe2O3. Okay, so in this case we started with 8.34 times 10 to the negative 2 grams of what? That would be iron 3 oxide, and we know we have to cancel the mole Fe2O3. Okay, see which one is, oh, actually made a mistake, because now you cannot actually cancel the mole. What happened? Where's the technology when you need it? Let me pause and try to resolve this technical difficulty. Let's continue with the solving this problem. As you can see, this one is the grams of iron 3 oxide has to come down to the bottom, and now you can actually switch them to the mole of iron 3 oxide. And you can see when we work down those problems, the molar mass, 1 mole of iron 3 oxide is equivalent to 100. 1 mole of this is 159.7. The grams cancelled, and you got the mole. I don't memorize. Should I multiply? Should I divide? The units tell you what to do. Then now you just clean up the math arithmetic. You can arrive as 5.22 times 10 to the negative 4 moles of Fe2O3. Moles of Fe2O3. So now let's pause the screen and take a look at 2 more similar questions, and to see whether you can handle it. If you can handle it easily, you are good for this particular section. And question number 1 is how many grams of nickel 3 hydroxide. Don't worry too much about it. You have no idea what I'm talking about, because you're going to later on in a separate unit, we're going to talk about ionic compound, covalent compound, how we name them. In this case, I'm going to give you the formula, And this one is going to give you the hint. And actually, you will be having nickel, oxygen, and the hydrogen. Nickel, you have 1, oxygen, you have 3, hydrogen, you have 3. Remember, this parenthesis is actually the number outside the parenthesis indicating how many of this entity defined by the parenthesis will appear again and again. So we listed it out here, and let's take a look at the molar mass for each element. So for nickel is 58.7 grams per mole. For oxygen is 16, hydrogen is 1. So then this one will stay 58.7, and this one is going to have 48. 3 times 16, so then plus it's just 3. It's 3. Add all of them together, you'll have 537.9 grams per mole. Okay, and but that's just covering the molar mass. So actually the real problem, 3.19 times 10 to the negative 4 moles of nickel 3 oxide. And you want to convert it into grams of the same thing. So then because of the space limit, I'm not going to reproduce what's inside the bracket. What you have here is essentially 1 mole of this nickel 3 hydroxide equals how many grams? That will be 537.9, and this one gives you the answer. So if you can clean up everything, and this one will give you 6.36 times -2 times -2 of grams of this compound nickel 3 hydroxide. Okay, nickel 3 hydroxide. And now let's take a look at the second question. It's how many moles of barium phosphate? This formula in 34.23 grams of the compound. You will have the same approach because you know you have to have the molar mass. So Ba you will have is, how many do you have? 3. And P, how many do we have? 2. Oxygen, how many do we have? 16. Barium. What's the molecular weight? What's the molar mass for barium? 137.3. And that will be phosphorus, it will be 31. Oxygen will be 16. Okay, so you multiply those, you're going to get 400. $411.9, and this one has 62, and this one has 64. Add it all together, that will be 537.9. And just realized I made a mistake up there, and actually this one is not correct. Made the wrong one, sorry. And this one is definitely not going to be correct. And we're not going to get that. And the answer is not going to be like that. So in this case, let's correct the first problem, and you can tell, and this one will be the answer 109.7. 109.7, and there will be 109.7. Plug in the numbers, and you will get 3.50 times 10 to the second, 10 to the second, 10 to the negative 2. It's 10 to the negative 2. Okay, 3.5 times to the 10 to the negative 2. Okay, and that will be the answer for number 1. That will be the 3.50 times 10 to the negative 2 grams of nickel 3 hydroxide. And now you're going to start with 34.23 gram of the compound, and that will be barium 3PO4 And now you want to go to, you continue on this side, you want to go to mole of the same compound, the barium. Then you say, oh, I gotta put the molar mass. One more of that equals how many grams of the barium? So one more of that equals 537.9. You put it in the math, and this answer should give you 6.32 times 10 to the negative 2 moles of the barium compound. Okay? Alright, so sorry, this one, it's a bit messy, but I hope you get the message. You're going to get the message. So in summary, in here we continue the discussion with the mole. Okay, central mole. Remember, we have this triangle, number of particles, and this is 6.022 times 10 to the 23rd. On this particular triangle, it will be mass in grams, and this is also the molar mass in grams. We talked about the molar mass for elements, and in this case we talked about, in here we talk about the molar mass of compounds. Okay, so it will be add with breakdown of all the elements that made up the compound, then add all these atomic mass together. And as soon as we get the molar mass of the compounds, then we can actually convert between the mole of the compound and the mass of the compound. With that, I conclude this vocast, and please go to the find the corresponding worksheet for additional exercises. Thank you very much for your attention.